Welcome to the session on DFT Properties Part 1. In this session, we will discuss about the properties of DFT. The first property of DFT is linearity property. It states that if we know the DFT of xn as x of k, then the of DFT of if we know the DFT of x1n as x1k and DFT of x2n as x2k, then the linearity property states that DFT of a into x1n plus b into x2n is equal to the DFT of this is equal to a into the DFT of x1k plus b into the DFT of x2k. It means that if in time domain uh, any signals are multiplied by some scalar quantities, a and b are scalar quantities, meaning it can take the values of integer values. So if we multiply the signals by, for example, a is equal to 2, b is equal to 3, then the DFTs also will be multiplied by 2 and 3 respectively. Okay, so this linearity property states this. The second we will do is the periodicity property. The periodicity property tells us that if we know the DFT of x of n, DFT of x of n is x of k known to us, then DFT of x of n plus n, where n is the period. Okay, capital N is the period of xn. Okay, so what is the DFT? DFT is also periodic, so k plus n. So it means that if you increase the signal x of n by a period capital N, then the DFT is also increased by the period capital N. Okay. Third is we will see the circular time shift. This property tells us that if the DFT of xn is x of k, then the DFT of x of n minus L. So what do you mean by that? That the sequence time domain is circularly shifted by L divisions anti-clockwise. It is the L is positive, okay? The shift is positive. How it reflects in the frequency domain? The DFT will remain the same x of k multiplied by, it is multiplied by a phase factor, okay, e to the power minus 2 pi by n into k into L. In twiddle factor form, it is written as, this is written as equal to W n k into L x of k. Okay, this is equal to, okay. So now in order to understand it better, let us take some numericals on this, okay, on the circular time shift. Find if numerical, if xn is equal to 1, 2, 3, 4 and its DFT x of k is 10 minus 2 plus 2j minus 2 minus 2 minus 2j is known to us, then find the DFT of 1 xn 4 1 2 3 and x2n as 2 3 4 1 2 3 4 1. Now, given this numerical, what we have to do first, we have to find the relationship between x1 n and x. Now we will see that this this is your x of n. X of n, if I arrange in a circle, x of n 1, 2, 3, 4. Okay, so this is an x of x1n. Okay, so what is this? 4, 1, 2, 3. So what do you mean by that? x1n is x of n minus 1. So xn shifted by 1 divisions anti-clockwise is your x1. So how to find out the DFT of x1? That we have to use the circular time shift property. So the DFT of x1n is equal to x of n minus 1. Therefore, x1k, the DFT of x1n is equal to W4, okay, k into L. So L is 1, so k into 1 into x of k. Okay. So now we will find out different values of x1 for different values of k. So for k equal to 0, x1 0 is equal to W4 0, x of 0 is equal to 10. For k equal to 1, x1 1 equal to W4 1, x of 1 is equal to W4 1 is minus j into minus 2 plus 2j is equal to plus 2j and minus 2j square. Okay, so minus 2 j square. So this is your plus 2. Okay. So then k equal to 2, x1 2 is equal to w4 2 into x of 2 is equal to minus w4 0 0 x of 2 is equal to minus 1 into minus 2 is equal to plus 2. Okay. So we will now calculate for k equal to 3, x1 3 is equal to w4 3, x of 3 is equal to minus w4 1 into x of 3. This is equal to plus j into minus 2 minus 2j. Okay. This is equal to your, so minus 2j and minus 2j square. So plus 2. Okay. Therefore, x1k is equal to, in sequence form, can be written as 10 comma 2 plus 2j plus 2 minus 2j. Okay. So then we will find out this x2n. Okay. So let us find out x2n. So what is x2n? x2n is 2341. Okay. So let us now find out the DFT of x2n. Okay. DFT of x2n equal to 2341. Okay, so how it is related to x of n? So this is your 1, 2, 3, 4 xn. And what is x2? x2 is 2, 3, 4, 1. This is your x2n. How they are related? They are related by two ways. Okay, so let us see. x2n is equal to x of n minus 3. So if you give 3 rotations anti-clockwise, 1, 2 and 3, then this 2 will come here, okay, and 3 will come here. Or x of n plus 1, or you give anti-clockwise shift, okay, to x of n. Okay, so of these two, the answer will be same. Either you can take this one or you can take this one. Since the calculations will be easier in since 1, so we will take this. Okay. Therefore, the DFT of x2n is x2k is equal to, if you see, it is positive k, so it was k into L, but since here k is negative, okay, sorry, L is negative, okay, L is minus 1, okay, so your DFT will be W, what is the formula? K into L into x of k. So L is minus 1. So it is equal to W4 minus k into x of k. Therefore, one by one we will find out for k equal to 0. x2 0 is equal to w4 0, x of k is equal to 10, k equal to 1, x2 1 is equal to w4 minus 1, x of 1 is equal to w4 minus 1 is plus j. Okay, so j into x1 is minus 2 plus 2j. Okay, so it is minus 2j square is minus 2 and minus 2j. Okay, equal to 2, x2 of 2 is equal to w4 minus 2, x of here x of 0. Okay. So here it is x of 2 is equal to w4 2 is minus 1 into minus 2 is equal to plus 2. Okay, and k equal to 3, x2 3 is equal to w4 minus 3, x of 3 is equal to minus j into minus 2 minus 2j is equal to plus 2j plus 2j and minus and plus 2j square is minus 2. Okay, so minus 2. Therefore, in sequence form, x2k is equal to 10 minus 2 minus 2j plus 2 minus 2 plus 2j. Okay. Okay, so 10 minus 2 minus 2j plus 2 minus 2 plus 2j. So this you can tally by direct twiddle factor multiplication, but in exams when they tell you to derive from property, so don't use the twiddle factor. This is only for your verification of the results. Okay, don't use the direct twiddle factor multiplication to find out the DFT when they tell you to find out the DFT by properties. Okay, so this you have to remember. Now, circular time reversal. Next property is what? Next property is circular time reversal. Okay, so this is the property number 3 4. Okay, so circular time reversal is property number 4. Okay. So this is your property number 4. Okay, circular time reversal. So what do you mean by that? When a sequence is reversed in time, circularly reversed in time, how a DFT is affected, it is also circularly reversed. Okay. Since the negative index does not have any meaning, you will see that it is written as added with capital N, the modulo N. Okay. So in order to make the index positive, the modulo has to be added with it. Okay. So if DFT of xn is equal to 1, 2, 3, 4. Okay. This is your x of n. If I circularly reverse it, x of minus n, how it looks like 1, 2, 3, 4. In sequence form, x of minus n is equal to 1, 4, 3, 2. So if x of n DFT is x of k is equal to 10 minus 2 plus 2j minus 2 minus 2 minus 2j is known to us, then what is the DFT of x of minus n? This sequence. What is the DFT of x of minus n? Let the sequence be written as x1n. So what is x1k? x1k will be the DFT x of k, but reversed in k, anti-clockwise you have to go. So if I arrange it on the circumference of the circle, then 10 minus 2 plus 2j minus 2 minus 2 minus 2j is x of minus k. Therefore, in sequence form, the DFT of x1k is written as 10. You will have to go anti-clockwise, minus 2 minus 2j minus 2 and minus 2 plus 2j. Okay. So if one thing you have to observe here, if you see when the sequence is circularly reversed, okay, only these two positions are changed, but the other positions 10 and minus 2 are remaining intact. What I mean that what is the difference between xk and x1? Okay, 10 is remaining same. This second and fourth position, they have interchange with each other. Okay, so this is true for capital N equal to 4. When the number of points on the circle is 4, this is always true. So you can quickly do in the exam, change the second and the fourth position of the sequence to write it anti-clockwise version of the positive sequence. Okay? And a clockwise version of the positive sequence. Okay? Now, with this, we will conclude the part 1 of your DFT properties. We will continue the other DFT properties in part 2 of the DFT properties. Thank you.